Alright, we made it to the very last lesson, 22.3, using the quadratic formula to solve equations. So again, in your packet you have examples, look them over, use them. Pretty much I'll be just doing live action examples that are the practice problems that you need to be doing. So in your packet, the first thing they ask you to do is use the discriminant to determine the number of solutions for each quadratic equation. So this is something I pulled from the internet just to kind of give you a visual. If that discriminant is positive, what that means is, let's say we're going to use our discriminant, which is taking our b value and squaring it and taking away 4 times our a value times our c value. Let's say we work that out and we get a positive. We will have 2 real roots. So our parabola graph will hit the x-axis at 2 places. Let's say we work that out, that b squared minus 4ac, and we get the answer, which is 0. That means we will have 1 real root. And that parabola hits that graph at least once. And last but not least, let's say we get a discriminant and it's a negative result. That graph will not hit the x-axis at all. In fact, there will be no real solutions. So we're going to make a determination based on what we get for our discriminant. So let's identify first our a value, b value, and c value, which would be 2, 6, and 15. Let's plug them in their places. So I like to label. Our b value would be 6, our a value would be 2, and our c value would be 15. So we'll work this out, and that would be 36. Go ahead and just pause right here and figure out what 4 times 2 times 15 would be. And that should be 120, negative 120 I should say. And then if I subtract those two, again pause, work it out, I get a negative 84. I get a negative discriminant. So as I'm looking here, would I get 2 real roots, 1 root, or no roots? That would be no real roots. By the way, in your packet they do have a kind of, as I'm making my no look like a no, you can actually record this into your packet if it's helpful, but you also have something similar in your examples as well to make that determination. Let's continue right along. So here it says identify your a, b, and c and substitute it into the discriminant. So our a value, b value, and c value. So that'd be 3, negative 5, and 15. Okay, our discriminant is b squared minus 4 times ac, which would be negative 5, 3, and 15. So that would be 25. Go ahead and take some time and figure out what that would be. Pause if you need to, but work it out. That should be about negative 180. So we'll go ahead and work that out. Again, pause if you need to and work that out on your calculator if you need to. That would be negative 155. So that would be a negative discriminant again. And if that's a negative discriminant, would I get 2 real solutions, 1, or none? So I'm looking at here, it looks like it's again no real solutions. And this is nice because at least we'll know, will we get 2 answers? Is it worth the effort? Will I get 1 answer? Still worth the effort? Or will I get no real roots and probably should just leave that one alone? Okay. On the next one, we're actually going to solve using quadratic formula. Again, if you skipped ahead, make sure you're looking back at your packet to look at the examples on how do we solve using quadratic formula. But let's go ahead and go through this one. So we have 3x squared plus 13x equals negative 4. We'll go ahead and solve by sending this out. What's the opposite of a negative 4? Positive 4. So that would be 3x squared plus 13x plus 4 equals 0. So we'll go ahead and identify our a, b, and c value, 3, 13, and 4. So I'll write this as negative b plus or minus b squared minus 4ac. So that would be 13 here and 13 there. 3 here and 4 there. All over 2 times a, which is 3. So we'll go ahead and simplify this and figure out that this would be negative 13 over 6, because 2 times 3 is 6. We'll go ahead and, just like it says here, we'll simplify this. So if you simplify 13 squared minus 4 times 3 times 4, take some time, work that out. So if we work this out, we find that this is actually 121. And from our perfect squares, we actually know that 121 is 11. So that would be negative 13 plus or minus 11 over 6. So I can actually work this out into two solutions, either negative 13 plus 11 over 6 or negative 13 minus 11 over 6. Take some time to work out each one of these, and that would yield a result of negative 2 over 6 or negative 24 over 6, and that would reduce down to negative 1/3 or negative 4. Okay, so we did that. Let's continue on. Let's do another problem here. So let's rewrite the equation in standard form. So I have 2x squared equals 7x plus 15. What I'm going to do is move this term over here by doing the opposite. And I get that so far. I'm almost done. Everything's almost over. What's the opposite of a positive 15? A negative 15. Alright, so now I'm left with 2x squared minus 7x minus 15 equals 0. So that would be a equals 2, b equals negative 7, and c equals negative 15. So again, so we're going to be doing our quadratic formula now. That would be the negative b value plus or minus square root of b squared minus 4 times ac all over 2a. So that would be negative 7, 2, negative 15, and 2. So we'll work this out. The opposite of a negative 7 is a positive 7. 2 times 2 is 4, and we're going to take some time to actually simplify this out. So pause if you need to and figure out what this would be under the square root. So pause right here and figure out what would this be equal to. And if you found that out to be 169, and we could actually square root that. In fact, square root of 169, if you haven't figured that out yet, on your calculator would be about 13. So that would be 7 plus or minus 13 over 4. So we'll do the positive result. 7 plus 13 over 4 and 7 minus 13 over 4. If we simplify this further, that would be 20 over 4. We simplify that further, that would be negative 6 over 4. If we simplify that even more, that would be 4 goes into 20 5 times, and if I simplified or reduce that, that would be negative 3 over, sorry about that, negative 3 over 2. Sorry about that 3 there, guys. Negative 3 over 2, and 5 would be our result. Continuing right along, let's go ahead and solve using the quadratic formula again. So that'd be 4x squared equals negative 7x minus 2. Let's go ahead and move our terms over. Opposite of a negative 7x, positive 7x. So that would be 2, 4x squared, positive 7. I'm going to kind of rewrite because I ran out of room here. So that'd be 4x squared plus 7x equals 2. Opposite of a positive 2? Negative 2. And so I'm left with 4x squared plus 7x minus 2. Let's go ahead and identify our A, B, and C value. Let's go ahead and write that out. So that would be x equals negative B value plus or minus our B value squared minus 4 times AC all over 2A. Let's put their numbers in their place. 7 and 7, 4 and 2, and 4. So opposite of a positive 7 would be negative 7. 2 times 4 is 8. And then let's go ahead and simplify what 7 squared minus 4 times 4 times 2 would be. And go ahead and take some time right now. Pause if you need to. Work that out. So that would be about 17. And if I actually square rooted 17, that's probably not going to get me a perfect square, but we could still work that out to be about 4.12. So that'd be negative 7 plus 4.12 over 8. Let's go ahead and work that out. Negative 7 plus 4.12, negative 7, sorry about that, minus 4.12 over 8. So that would be about, let's go ahead and work that out. All right, so that would be about negative 2.88 divided by 8. This would be about negative 7 minus 4.12, negative 11.12. Again, go ahead and work each one of those out and see what you would get. And that would be about negative 0.36. And we would divide this one out to be about negative 1.39. Okay. We're going to actually continue this on in our next part 2 of this lesson.